All right, welcome to this video. We are starting a complete new unit. I want to go through some vocabulary here to start. We've kind of moved away from number sense. We've done a little bit of geometry this year. So let's look at some of these words. So we're in unit 3. We're in linear relationships. I'm going to highlight the first 4 letters there. What word do we see there? We see line. So we're going to be looking at all mathematical relationships that form a line. And there's a lot of them. In your math careers, you're going to study lots of different types of relationships. Linear, exponential, quadratic, and polynomial, and so on. So we are going to study all relationships that form a line. Now, we're going to start with a specific kind of linear relationship, which is called proportional. Okay, you've studied this before. Okay, you studied this last year in 7th grade. Okay, so let's go ahead. We're going to zoom out here. I'm going to talk about some of our vocabulary words here. So the first vocabulary word is proportional relationships. Okay, and I'm going to read you the vocab word. We're going to talk about the pictures you see in the middle. So two quantities, x and y, have a proportional relationship if y is always a constant multiple of x. A relationship is proportional if it can be described as equivalent ratios. So in 7th grade, you went pretty detailed on proportional relationships. This year, we're going to look at proportional relationships as they exist on a graph, on a table, and in an equation. Okay, so that's what we're going to be looking at. And there's a specific multiplier that takes and multiplies x by y. Remember, in the table, we have x, y. So this one's kind of hard. It's 4.24. That's some real-world data there. You know, you might have 5 multiplying, where this would be 5, 10, and 15. So this is a proportional relationship because it's a straight line through the origin. Okay, and we'll talk more about that as we go. All right, coordinate plane. One of the most important things that you learn in math. I mean, it's one of the most important things that we talk about. You've talked about it in 6th and 7th grade. We're going to continue talking about it here. So the coordinate plane is a two-dimensional system in which the coordinates of a point are its distances from the two intersecting perpendicular lines called axes. All right, that's a big fancy thing. So we have the y-axis. It's vertical. We have the x-axis. It's horizontal. Okay, so like this ordered pair right here is 3 from the origin and 2 up, so it would be 3, 2. All right? And down here with coordinate, I'm going to skip to coordinate. Okay, an ordered pair or a coordinate tells us a location on the coordinate plane. Remember, all coordinates are x, y. Now, a graph is something that just displays relationships between 2 variables, so height and weight. All right, let's flip over to the back. Let's look at some examples. We're going to talk about 4 quick examples here. So, Felicity babysat 2 hours each night for 10 nights. She earned a total of $180 babysitting. Felicity wants to calculate her hourly rate. How much did Felicity earn per hour? So what we are looking at is dollars. So earn, we want to look at this. So earn per hour. That's kind of the clue there. So what we're looking at, earn, we're talking dollars. On the bottom of the fraction, we're talking hours per. So when we're talking about unit rates, which is what we're talking about right here, a unit rate means, okay, and you talked about this in 7th grade, per 1, okay? So per, remember, per is division. Okay, whenever you see the word per in a math problem, you're thinking division. In rates, that if you're driving to school on the school bus and you look out and you see a sign that says 25 mph, that means miles per hour. That is a rate. That is how fast a car, truck, whatever is allowed to drive on that road at that time. Okay, so we got to figure out, so 2 hours each night for 10 nights. So she worked a total of 20 hours and she made $180. So we're going to put the $180 on top. We are going to put the 20 hours on bottom. Okay. And if we take 180 divided by 20, this is equal to $9 per 1 hour. All I did there was divide by 20. I reduced my fraction. So the answer is Felicity earned $9 per hour. Okay? Oop, that's not what I wanted to do. $9 per hour. There's your answer. These two fractions are equivalent, meaning we have equivalent ratios. All right, let's look at example 2. Julie is planning a party and comparing the cost of different banquet halls. Parties R Us charges $20 per person. At Eloquent Banquets, the charge is $15 per person. Complete the table to show the total cost for the different number of people. So, this is a little weird. So, here at Parties R Us, their charge is, they are $20 per 1 person, okay? So, if we want to, we have to multiply. So, for 0 people, it would really be $0. If you don't have a party, they don't charge you anything. So now, for 25, 50, 75, and 100, we're going to have to do a little bit of math here. So we're going to take our rate, $20 times the number of people, which would be $500. Okay, so what we're seeing here is for every 25 people, it costs us $500. So then we have 25 more people, so that'd be $1,000, $1,500, and $2,000. Here at Eloquent Banquets, they're charging $15 per 1 person. Okay? So when it says per person, you're really thinking per 1. Okay, so this would be 0. Let me go and do a little bit of math. 25 or $15 times 25 people. Well, that's 28. I can't type. Is $375. Okay, which means this would be $750. Doing some math in my head. Let's not do that. 15 times 75, 1125, and then this would be $1,500. So a table like this would allow us to begin comparing. All right, if I go to Eloquent Banquets, I say $500 if I'm inviting 100 people. All right, now here we have a table that's already made, and it's trying to ask us So really, what it's trying to ask us is, how many bracelets does Casey make per hour, and how many bracelets does Allison make per hour? Okay, and are they consistent? So I'm going to kind of do some division here. Right here, I'm going to do 150 divided by 5. So when we'll talk a lot about this. When we're trying to find their unit rates. Okay, unit rates is always y divided by x. Okay, so remember, in a table, this is x, this is y. So I'm going to take 150 divided by 5. So 150 divided by 5. Make this bigger so y'all can see better. Then it was 180 divided by 6. Okay, that's still 30. 210 divided by 7. And 240 divided by 8. So all of those are 30, and so on. So if we take and we divide y by x, okay, y over x, to get our unit rate, we get 30. Okay, 30, 30, 30, 30. So we could come over here and say, Casey makes 30 bracelets. Pardon my handwriting there, it didn't work out real well. Per hour. So now let's look at Allison. Allison's data looks a little funky to me. So I'm not sure if Allison makes a constant unit rate. So let's do 160 divided by 3. So I'm going to clear this out. 160 divided by 3. I'm going to go a little slower on this. So there she made 53 1/3 bracelets an hour. Then we're gonna do 360 divided by 7, which is 51.4 bracelets. Okay, and then 510 divided by 10 is 51 bracelets an hour. Okay, and then 610, oops, I forget already, divided by 12, she made 50.8. Okay, so 50.8. So Allison does not make a constant number of bracelets. So therefore, we cannot say that she has, there's a unit rate there. Okay, so she does not work as consistently as Casey does. All right, we're gonna put some ordered pairs on a graph. I'm gonna talk about graphing. This is super important. You learned this in 7th grade. This is 100% a review. Every one of you should exactly know what I'm talking about. Remember, this is the x-axis. This is the y-axis. Every ordered pair is x comma y. So the first number is x, the second number is y. So if I am to look at the first number being -3 and the second number being 4, okay, so what this says is I start at the origin, which is right here at the center, and I go 3 to the left, okay? The first number tells us to go right or left. The second number tells us to go up or down, okay? Right and up are positive, left and down are negative. Okay, so this is just one of those things in life you gotta figure out. Okay, I can't give you tricks and hints and things to memorize this. You just gotta remember. So the first number is x. We're gonna go -3, and I'm gonna kind of show you with this. So we're gonna go 1, 2, 3. That's -3 on the x, and then 4 on the y. 1, 2, 3, 4, and that's where we put our dot. So our dot will be at -3, 4. So that's A. Now B is 3, -1. So I need to go back to the origin. 1, 2, 3x, -1y. That's where I land. So B is here at 3, -1. C is at 5, 2. So I'm going to go 5 on the x, 2 on the y. Let's put a dot. You notice how I'm always going back to the origin. That's C. Now for D, -1 on x, -4 on y. So it's right there. So a coordinate is really a location. So this is an address, okay? D is located at -1, -4. So I must go 1 to the left and 4 down. This number right here says left 1, down 4. This here says right 5, up 2. You're just gonna have to remember this and learn. All right, thank you for paying attention and following along.